the only one presenting. Oh, good. I'm not going to just have to juggle. We'll do a few more minutes as people jump in here.
Hi, Anya.
Hello. Matthew.
Usually we've got about 20 people, and so we're probably, if we get one or two more, then it's probably about time to start.
Okay, sounds good. You tell me when.
Yeah, sure. I guess we should check that we have all the presenters that we're expecting on the call. See, yep, looks like everybody's here. Oh, do we have? Is Kate here?
I don't think so.
Yeah, I don't see her on the list.
I'm talking to Kate via Slack, so I can just shoot her a message real quick.
Oh, perfect. Yep. And I know Charles can't be here today because he's doing some Avita Ed train the trainer stuff.
Oh no, then he won't learn how the web tests work.
We're gonna send him the video so we can have the Gospel of Catch.
Awesome.
Advanced features.
Kate's previous meeting is running long, so I think she'll be here when she can.
Okay, perfect. All right, I think we should probably go ahead and get started then.
Okay. I should be able to screen share here. We have slides. Do you see the full slides, not the weird presenter view?
Yep.
Okay, awesome. All right, so hello everyone. I'm going to try to look at my screen here. There. So today we wanted to talk about a couple of concepts that are those sorts of things that are important in software design and development, but easy to skip over. And so I'm going to talk about. I'm going to try to advance the slides. There we go. I'm going to be talking about the high-level concepts of these things, BDD and TDD, which I'll tell you what they stand for in a minute. And then Kate is going to tell you what it's really like in industry, because I have only ever been in academia, so I don't actually know if any of these things really happen. And then Santiago is going to show you how to do some of it with Catch, and then Emily and Alex are going to show you how to do some of it for Emscripten type testing. I think that I correctly conveyed who's doing what. So we'll jump in so that we don't take too long here. Okay, so BDD stands for behavior-driven design. So that we'll talk about exactly what that means more in a minute here, but it's just this idea of trying to figure out like what your user, what your client actually wants to do, and solidify that in kind of a formal way before then writing the code. And then TDD stands for test-driven design, where you write tests to make sure that your code actually does something correctly before you actually even write the code. So these are both kind of obviously have this thing in common of you do stuff before you just jump in and write code. I think a lot of us probably get into the habit, learn how to program initially by just kind of sitting down and typing out your subject code, what we call it, right away, and don't do a whole lot of planning ahead of time. And that works for small things. But once you start handling bigger projects, and even for smaller stuff, it is very useful to do some planning in a sort of formal framework beforehand. So what does that actually look like? So user stories can have lots of different levels of formality. It certainly is the case. I've heard from people that like some places do this, but don't do it quite, rigidly into this format. But the formal format is to, have your feature name kind of as you would probably anyway on your to-do list, and then to try and express the the goals of that feature in this sort of specific style where you say like as a stakeholder. So I give you a couple of examples. You might be thinking about this from the shoes of a researcher or a teacher or a student. If you're doing code that would be used by students, there's lots of different examples that we could start thinking of, but you want to think about your user's perspective. And then you say, I want to accomplish something, some sort of task. And then, so that's kind of you might do that naturally or be thinking about that naturally, but then you also want to point out what the goal is, right? And so this is that whole, the immediate gizmo to solve something might not actually be the best way to do it. And so being clear on what the goal is, what the tasks they're trying to accomplish, and why they're trying to accomplish that can be helpful in sort of clarifying exactly what you want to do. So a couple of examples, if you're okay, we need command line arguments, but why do we need command line arguments? Well, if our client is a researcher and they want to be able to change settings on the command line so that they can run experiments more easily, this is something that I do all the time. That is kind of how you would fit that sort of a feature into this format. And this is kind of one of those places where you can see that so that I can run experiments with different settings easily via the command line, there might be other ways of solving that problem other than command line arguments. And so being clear from your client of what their goal is might help you identify a task that, a way of solving it that's different than your immediate instinct. And then similarly, we could have a teacher might want to have a nice visual interface so that they can use it with students. So these are just a couple of examples. Any questions about kind of just this format for user stories? Normally I do this as super interactive where I make my students do a reading beforehand and then don't tell them anything and just ask them questions, but that doesn't work super well with this format. So you are spared from having to just answer all of this yourself. Okay, so once we have an idea of the format of user stories, there's a couple of more things to think about to try to make them better. Industry loves doing their acronyms. So here we have the SMART acronym. So they should be specific. Vaguely stated things are not easy to do. And you don't even know if you achieve them. So we want it to be as specific as possible. We want them to be measurable. We want to know that we have finished a thing, and we want to know if we're making progress towards finishing that thing. We want them to be achievable. This is one of those where a task is almost always going to be more difficult to actually do than you think it's going to, because you don't think about all the ways that it could go wrong. And so you definitely want to feel like it's achievable before you start it, because then it might actually maybe be achievable. If you don't feel like it's achievable to start with, then obviously it's probably not going to be easier than you think it is. Relevant, we want to keep focused on the goals of the client, not go off and implement things that aren't going to be useful to them. And then time box. So so a lot of this comes from a methodology that focuses on doing things in 2-week blocks. But so it's this whole, you should try to do something that you think you can accomplish within a short period of time, because again, it's almost always going to take longer than that. And so you want to break these things down into as small of pieces as possible, so that you can actually make progress in progressive chunks. Okay, so if we then switch to the other acronym, or another acronym, so TDD is test-driven design. So we know what the user wants. We have a user story. These two kind of concepts can be done separately, but they work really well together. So we know what the user wants. Now we should write some tests. Before we even write the subject code, we should write tests. And we want to use this red-green refactor cycle. So this is talking about that you should write your test and you should run it immediately and make sure that it fails. If you write a test and then write the code to solve that test immediately and then run it and it passes, you don't know if that means that your code works or if you just wrote the test wrong and so it would have passed no matter what. So always make sure that your test fails first, then write the code to pass it, and then make sure that it passes. And then the refactor part is that like once it's passing, then you can safely like change your code around to make it, you know, better organized, and you'll know that it will actually work because you wrote tests for it. So questions about either of the last couple of slides? I can't see the participants list, so if you're like raising your hand or something, I can't see, so you need to just like shout out. Okay, cool. So disclaimer, test-driven design feels really weird at first, I think at least. It can be very difficult to try to like write a test when you don't know what the code will be yet, and that is definitely uncomfortable. And so it does force you to kind of like imagine the code you wish you had. Imagine, like you start thinking about how you might write the code because like you kind of have to a little bit, but you should really practice this process of like forcing yourself not to write any code, any subject code until you've written the test. And then, and eventually that becomes like more natural way of thinking about things. I've taught classes where I introduce this to students and, you know, kind of force them to do it throughout the semester. And by the end of the semester, they feel much more comfortable and it comes much more naturally. So it's definitely one of those where you just get better with practice, like pretty much everything. So there are lots of different kinds of tests. Before we talk about specific kind of categories of tests, in general, we want tests, this is another acronym, it spells out FIRST. So we want them to be fast. We want to have tests that are like as small as possible and as simple as possible to test the like given code so that they run quickly. If tests are slow, then developers won't want to run them frequently, and so they're like, then that's the whole point of tests. We also want them to be independent, so we don't want it to be that like one test always has to take place before the next one because it sets things up a certain way, because then that's a certain amount of dependence that then is, you know, making it difficult for you to know what's really going on with your system. We want them to be repeatable, so if there's randomness involved and things, you want to use your random number seed so that you can make sure of what's actually happening. We want them to be self-checking. This one is like why we have so many nice automated test suite things. If you had to just like go through and look at output each time, that's again like people are going to start getting lazy and not wanting to do that. So we want it to just be beautiful and just say all tests pass or things don't pass. And then we want them to be timely, which is a little bit shoehorned into this acronym, but it's just this idea of like, you want to write the test as like near to the code as possible, ideally before the code. But if you like find yourself, oh, I wrote this code, I know I should have written that test beforehand, but I didn't, you should then write the test right then, right? The best time to write the test was 5 minutes ago or right now. You don't want to, I always, you know, when I'm teaching a class, I say you don't want to, at the end of the semester, write all of your tests because you didn't write any during the whole semester. So for you in this context, you don't want to write all your tests at the end of the month because you didn't write any tests during the month. So 5 minutes ago was ideal, right now is the best actually feasible option. Questions about any of those? Debate? Okay. So once you have like a big software project, you want to start thinking about a concept called code coverage, where you're measuring how much of the code is being tested and how thoroughly. So this seems like a really simple concept, but is actually really complicated on just like what kind of coverage you're measuring. There's many more than these two, but just kind of to give you kind of an idea of the different factors that you have to take into account. S0 method coverage is where every method is being called by a test. So just like while a test is running, it calls a method, check. But there's a lot of things that aren't tested in that context, right? Like it might only test the method with a certain value of input. It might only test that method running a certain way. And so a more extensive type of coverage is C2 path coverage, where every path that can be taken through the code is tested. And so that would be like every if statement evaluates to both true in a test and false in a test. Every switch statement has each of the cases evaluated. And then ideally, obviously, like the inputs to a method might have to change in order to get the different parts to go. That's still not necessarily covering everything. There's an even more in-depth version, but those things start getting, excessive and infeasible, that's the word, at a certain point. And so we always talk about like how much coverage there is of different kinds, and you just have to call things good enough at some point. Thorough, so code that is being thoroughly tested and well tested has more lines of code than test code than subject code, and so like ratios of like 3 to 1 of lines of test code to subject code are not unusual and often higher. And then you also will have, like we should definitely have 100% method coverage, and then maybe like 20% path coverage for the super important things, just depending on what, how important different pieces of the project are. Questions about that? Okay, I'm giving you a super high level overview of all of these high concepts. You don't need to perfectly understand things. I just want you to be aware that people think about these things, and these are ways that some people approach things. And we use them in empirical somewhat. Okay, last slide. There's a number of different types of testing. So a unit test is when you are like testing one component, often just like one function, method, procedure. Those are all words that mean nearly the same thing. There's also a functional test that is just kind of the next step up of like it tests like a group together. If there's like several methods or classes that work together frequently, you would could test that bundle together and call it a functional test. Then there's also integration system level tests where it tests the whole system at once. So I have a lot of these in my software, or this is the main type that I'm worried about in my software, where it just like runs a whole experiment and checks to see if the results are exactly the same as the last time that I ran it. So that's, checking the whole system, did anything change? And then there's one other thing that I think is a useful one to know about. These are not all the types of tests that exist, but characterization tests are when you have untested code, often called legacy code, that you don't know what it does. You can make a test to capture the current behavior, and then you can refactor and figure out what it actually does, and hopefully make it more readable and easy to understand what it does without breaking anything. I mean, this doesn't guarantee that you won't break something, but it makes it more likely. So characterization tests are a good way of getting to know code that is untested, that you don't know. And so that is something to think about trying if you feel like contributing to Empirical's untested sections. And with that, we're gonna turn it to Kate to see if everything I just said was a lie.
Nope, I think it just depends on where you are. So my name's Kate. I, before coming to MSU, worked as a software engineer for a company called Smooth Logics. And we made an enterprise scale piece of software that was for engineer to order companies, where the kind of companies where you go, I want a robot or machine that does this. And then they have a bunch of engineers on staff of various types, like mechanical and material and electrical and all those guys. And then they go into SolidWorks usually or some other CAD program, and then build out the specs. And then it's so that initial order of an idea versus a product number. The usual pipeline for any business is you have a product number that's ordered, but this is an idea or desire that's ordered, and then all the way through to receiving payment and printing out all the stuff for them for the receipt and taxes and all that garbage. So a lot of different pieces hooked together, like accounting versus ordering and all the different bits and pieces. And so we did almost exclusively integration testing, but it was test-driven development. So the big thing that we found with the using like user stories, and like Anya was saying, we didn't do it in the exact format. Like usually once a professor is not checking your stuff, is if you're at a company that doesn't care, people just kind of scribble them down. The big thing was like they're really easy to capture during a meeting with the actual stakeholder. So the people who are buying, the software was licensed by seat number. So just like you get like one copy for yourself of Word, companies would get like a year of 5 seats or 30 seats or however many people they needed to have access to the program. And so we talked to them about what they wanted to have happen. And so it'd be something like, when I entered this in SolidWorks, I want the integration pop-up to come out and be able to click save, and then it enters it all into the actual company's database, and it changes something about the number of XYZ available, right? Or it sends something to ordering to know that now it's time to order the parts that I need to build whatever I just put in. And so that means that developers don't have to do that. The business manager person goes and does that. And then usually that user story was cobbled together from multiple, because what accounting wants is not usually what the business folks want, is not necessarily what the engineers want. And so they kind of take everything and see what's conflicting and try and cobble together the best version. And also between different companies, since different companies are using it and some of them were very different from each other, they had different wants and needs. And so they make the thing. Then usually they'd send it to us as the dev team. The dev team would go, we can do all of this. Here's what it's going to cost you in terms of developer time hours. And some things they look at and go, oh, that's going to take one senior engineer 3 months to make. We don't want to spend, we don't care about it enough to do that. And scrap that or change it in a way to make it a lot easier. And then the thing about the test-driven development is you can break it up really easily so that one engineer writes the test and then someone else codes it, so that if there's a logic mistake in there, hopefully it gets caught because you have 2 sets of eyes on the problem now. Where if you write the code and then you write the test to test your code, the problem is you often write a test with the same mistake in it that your code has if there's a mistake. So it really helps to have the different person. And it also becomes fun because you're like on the other side of the room. One person's trying to write the test faster than the other person can get it to pass, and it's kind of back and forth. But usually it was all integration tests. Unit tests were just too time consuming and were only used when it was like you're trying to figure out a problem and it makes it easier. But in terms of if you did all unit tests, when you then go to run all your tests before pushing your code, it would take like a day because the software is so large. And so just doing integration tests caught the major bugs, because that's usually where they're at, is at the hinges. Like if you've made 1,000 doors, your door is probably going to be fine, and this door is probably going to be fine, but you might have built them together in a way that they're like going like this. And so getting weird race conditions and deadlock and stuff was the most common problems. So that like if I'm an engineer ordering X or changing a part that's already in the system, and ordering is over here trying to order said system, what happens if I click this at the same time they click that, and then you get weird behaviors. So that's what we did. It was all in C#, not C++, so I don't have experience with the tools we're going to go through next. But I got very used to doing the tests first and learned to really appreciate that red-green refactor cycle, and how especially you build up a suite of tests for your own code to always run before you push. And that automated thing of the confidence that you didn't break something when you add a new feature is really nice. I know a lot of you guys have had internships and jobs out there. I'm assuming at least some of you have had to deal with testing, because I know folks like Abby are sending code into space. Did you have lots of testing for that, I'm assuming?
No, which is a serious issue.
What?
Don't worry about it. there was some, but it was not done particularly well. Sometimes depended.
So, my favorite error that we had, so like one of the companies was the company making those big bottling machines for companies like Coca-Cola, like the room size machines that do crazy things in production. And they're like, yeah, the bottles are getting air. And I'm like, oh, like injected air? And they're like, no, air. Like they're getting launched off the thing. Because someone had changed the angle, but then it hadn't gotten saved properly in the database. And so the angle was incorrect. So like every 1,000th bottle would go whee on the production floor. So they didn't like that. Customer was pissed. What kind of testing did they do or not do?
That is a good question. I didn't work on a lot of the parts that were like really important, and I don't know what the code looks like because I wasn't allowed to see it because it's all classified. But on the parts that I did, there was some testing, but it was mostly, they had really bad code coverage, but it was, what's it called? I can't remember. But no, that was a big problem actually, was the lack of, because it was such a giant thing, and it was all written by like scientists instead of coders, and they didn't do a very good job of that.
It's really hard to convince the people paying for the code, which is usually not coders, that code coverage and tests matter. That was like a never-ending fight between the dev team and dev team leader especially, and the business folks. And as far as I understand from other friends working in industry and stuff, that's pretty universal, is people want the code, they want it now and as cheaply as possible. And usually that means few tests, if any. So then it cost them 1,000 more years in the long run, because like our problem is if there was bugs, it was like cost a lot of money, because these were like multi-million-dollar machines usually that were being built for people. So if things were misbuilt or misbuilt, it was not usually a safety issue. That was a pretty, like the launching stuff was a rare thing. Usually it was a money problem, but I can't, for safety critical things, that seems crazy. Yeah. So anyone else do testing at an internship or work? No, crickets. Anyone have any questions? Nope. Okay. I think Alex is next.
Oh, I sure hope not.
Yeah. Actually,
no, Santiago next?
Yeah.
Okay.
Yeah, you're fine. You got some more time there. So who here has dealt with a bit set inside Empirical? Okay. I'm sure you know, if you've ever gone into the testing file of bitset, that it's kind of scary. Just scary. There's no. It's just scary. Hang on. Let me share that.
I've been trying, but it hasn't been working. So thank you, Matthew, for fixing all of the compiling issues.
So here's the file where everything's getting tested. You can probably see here on the on the right side that it's a very long file. These aren't the tests. These are just functions for the tests. It's really scary. Here are the actual tests. It's just one test case, and it's 1,000 lines long. It's kind of scary. There was a bug that Matthew was having, and this is the reason there's so many weird things going on. And the reason there was this bug is because the tests weren't actually, well, had the tests been like better from, not better, but like more developed from the beginning, the bug would have probably been caught earlier. So yeah, this is how you usually do tests in Empirical. At least that's how it's generally done, where you have one test case, and then a bunch of requires, and then if the assertion fails, then the test case fails. So let me show you what that looks like. So this is how you actually make the test. For those who don't know, you just run make test dash and then whatever the file name is, and this just compiles the file and then runs it. So while that's happening, let me tell you a bit about what this is actually doing. Because this test case macro, which I lost because here, this test case macro is not actually part of empirical. It's actually part of catch 2. We're importing it right here, and like this file doesn't have a main because you do the main there. That took me a bit to realize when I was writing my own tests because they kept failing. I didn't know why. But yeah, the whole point of catch is to have one of those utilities that kind of automate tests for you, so that you don't actually have to compile and then like see out everything and then check that it's all right. You just kind of say, hey, this file, like this result should be false, and then test. Then the catch just tests it, make sure it passes. Right now it's running, and this file, since it has so many assertions, takes a long time to test. This is one of those tests that are always so whenever you push something to empirical, Travis, one of the automated build systems, actually runs all the tests, and this is one of them that always takes a long, long time. This was actually much worse back when every testing tools was inside the same file. So imagine this plus a bunch of other tests in the same file. Like that was really sad to maintain. So now, luckily, they're all in different files, but still, like, it's still not ideal just because you have a single test case. Yeah, see, it's like how many? What is that? 20 million assertions in 3 test cases. So something.
Yeah, like one of the nice things about doing tests first is that a well-written test documents your code.
Right. That's the whole point.
Yeah, and so this does not. This is confusing.
Well, it also doesn't have comments, which is also kind of bad for documenting things. I mean, there's some comments, so which is, I guess, good. But yeah, imagine one of these numbers like changing, and like, how do I know that's supposed to be? Oh yeah, everything's like how do I know that's supposed to be 1 and not 2? You know, like why is this number like that? It's probably like the max int or something, but like had there been a comment like max int, then you would know. Now I just changed that, and I'm gonna, so it's like a very small, like let's say that actually the result is different. Hang on, let me actually try and do something that will surely fail. There you go. So now the problem with catch, it's not really a problem. It's a problem with catch and how we actually do tests, is that it actually tries to finish the test case before actually finishing the program. So even though the test already failed, because this is clearly wrong, the test is gonna keep running until the end anyways, which is bad. Because when something fails, you want to deal with it. You don't want to like actually have to deal with all of this other boilerplate code that's doing something else, and that's likely not going to fail. Also, I lost the change, so there you go. Yeah, so that failed, and now if we actually, yeah, so like it tells you like why it failed. It does something nice with the requires and tells you like what's actually inside the required that wouldn't have happened anyways otherwise. So something looking into it, because I was kind of confused as to why we're using catch instead of like Google testing or something, is I found out that catch actually has some behavior driven development stuff built into it, and I kind of tried to do that with qcache. So this is a file we got it a bit ago. This qcache thing, actually, it's basically a cache that stores things in the order that they were accessed. It doesn't really matter. This is showing. I'm just showing you the for some of the methods inside qcache. You know, contains to check if there's something in the cache. Put things in the cache. Then this is the test. This was actually made in a way similar to behavior-driven development, because ideally you would have had like we mentioned before, you would have had the tests before actually writing the qcache. That's not actually how it happened. But at least this is more documenting. Like this is actually self-documented. You know, it tells you Yeah, I know that's like a meme saying, "Oh, my code's self-documenting," but like actually, this actually kind of tells you what you're doing, so you kind of know if something fails, that why it is that failed. So you have scenarios, which is okay. So the queue cache has to do something. In this case, it stores elements. So then, given a queue cache of a certain capacity, and then I just define a queue cache and give it a capacity. And then just check that the capacity and the size are actually like the capacity is actually a capacity and the size is actually 0, because that's the only time we do that, because if it doesn't work there, then the whole thing's broken. So then when elements are stored in it, and then you actually store some elements in it, and then you check that the elements are stored correctly, then they can be retrieved. So then you just try and get them, and if you get them, and if when you get them the answer is the one you expected, then the test passes. So then let me actually make this. This is going to be much faster because, it's not that long. But yeah, so it tells you all the tests pass in 8 test cases. And what you can do, let me see if I remember how. So there's a way to actually have it tell you when it succeeds, all the test names, all the like scenarios and what it's testing. It's not actually needed. But for example, let's change one of these values to something different, and let's remake the test. Now, when it fails, it'll actually tell us where it failed. So then it tells you, okay, scenario, queue cache stores some elements. Given a queue cache of a certain capacity, when elements are stored in it, and then it failed there. So okay, okay, there's something going on with either storing an element in it or checking that it can be retrieved. And if you see the expression here in line 33, it's trying to compare the 1 to a 0, and that's failing because 0 is not actually 1. So this is like, if had we broken something inside queue cache, this would have actually told us like what's broken and where kind of how to fix it. So something else usually doing when dealing with BDD and catch is that you have more than one test case. So here we had, let me Control F test case. Yep. So we had like 2 test cases, and inside of the test case we had all the tests, and they all share the same namespace. So you have to like break up the namespace with these, just to like have them not, because otherwise you would have to have like, instead of BS10, it would have to be like BS a million, because you have a lot of bit sets. So something about queue cache is that scenario is actually an alias for test case. So whenever you see test case in a normal test, you can actually replace it for scenario, and it will just, the only thing it does is change the scenario name. And then these are actually kind of like internal namespaces. So if you had 2 givens here inside the same scenario, like if you had another given here, they wouldn't share the same, like I couldn't call from a given in here, I couldn't call actually like this queue cache. I would have to make another one, which is pretty neat, and that helps you a lot with like differentiating namespaces. Same thing inside here, like the when here, you can actually refer to elements up 1 level, but I can't refer to elements in another 1, which makes sense, It's kind of like that actually makes sense. So yeah, catch also has these other functions which are pretty neat. This doesn't have anything to do with BDD, but I just like talking about them because they're very nice. Where you can test that something throws. So instead of having to like try catch and then like catch the exception and test that the exception's the right one, and that whatever, you can actually test that it's thrown with a string. So here, if we go inside get, we'll be able to see, we see that, oh, where is it? Here, there's a throw. We'll see that it's throwing an invalid argument with like saying, okay, that key's not in the cache, you can actually get it because it's not in there. So then we're just checking that it's actually not in there. I think this is pretty neat, and it just tells you like, so if we change that, it would actually tell us like, hey, this is failing for these reasons. Like it wouldn't, yeah, like it tells you, hey, this is not equal to this. Like you would see, had you thrown the wrong error, for example, it would have told you the different error here, which is actually also very interesting because not many testing suites actually do that for some reason. And now, instead of having to deal with code that's already made, I wanted to actually show you some new code that we've recently included in Empirical we haven't pushed yet, which is something called a container hash, which is used to hash containers. Because sometimes you want to have, so in C++ you have something called an unordered map that stores, it's basically like a dictionary in Python where you have like a key and a value. It's a lookup table. In general, you need the keys to be hashed. So you always, in an unordered map, you always need the keys to be hashable because they are sorted by their hash. In general, like something like a vector with elements in it, it's not hashable by default. Because you can put things in and take them out, so like that's not really very hashable unless it's constant. So this struct just kind of hashes a container. It's not really important how it works. You just have to know that container hash hashes containers that have things in it. So then here, I wrote some really bad test cases. It's just called test. There's no comments, and it does things that are not really very clear in what they're doing. So this is an example of a bad test. But if we make it, it'll pass, and Travis will be happy, and we'll be able to push our code. Question is, should we push it? What do you think? Like, would this be fine to push to Empirical? I don't think so. So then I came up with the idea of actually doing some BDD on it to develop some actual test cases that actually kind of test the functionality. They're very rudimentary, like, a container hashes containers. So if you have a container, then it's hashed. Like, sure, it seems pretty obvious, but you actually have to test that. Because if you don't, and it's not actually hashing them, or or you have collisions, then that's gonna break the another map. Like hashes are supposed to be quote unquote unique. They're not really unique, but at least they should be as unique as possible. So we can test that actually. We can, using the tools from Catch and what we learned from BDD, we can actually just set up some very quick scenarios. If I can spell. And we can actually do some testing. So since we already have here our scenario names and given whens and thens, we're gonna actually just copy them and it'll be fine. This is a good thing about BDD. Like most of your tests are already laid out. You just have to find a way to actually code them, which is the easy part. Most of us, when learning how to code, we like in school, you had an assignment that you had to follow, and okay, let's make sure this passes, and like sometimes you would use like Mirror or something like that to test like your code, and you get points. Like, oh, the test cases are passing, you get like 10 points, which is kind of like BDD, or at least tester in development, because you're like using the tests to make sure your code, like you're developing your code in terms of the tests. And then like when you leave school, you don't actually do that unless you're actually trying to do BDD or TDD. So this is kind of like that, this is kind of like an instructor told you, okay, this is supposed to happen, make it happen, and then you coded your thing. Here we're just doing the instructor side where we have the test trying to pass. So actually, Catch has this really neat feature where you can just call things by the same name they have here, and it'll be fine. So here we have a container hash. So we actually need a container hash. You can actually have a standalone container hash. You should actually have it inside another map. So we'll just make another map to make sure it's getting hashed correctly. So here I'm gonna make a map of, I don't know, let's say vector, like a vector of ints to an int, because I don't think I imported string. Nope. And then here I just call container hash. And then I tell it, hey, we're gonna be caching a vector. Now, I'm not gonna use an emp vector yet, because that's actually its own test. Just to make sure, in theory, like an emp vector just compiles onto a stud vector, but I kind of want to make sure that that's true, because if you don't do that, that can also bring some problems. Like imagine being in debug mode and then suddenly your code doesn't compile. That's not fun. So here, following the scenario, we have, okay, container hash some containers. So then you have a container. I mean, I guess this has to go in here, huh? My bad. There we go. And then we actually need a name for it. Map, sure. There we go. So then when some elements are put in it, let's do that. When elements are put in it. So let's put some elements in the map. So let's try and do it two ways. The first way is by making a vector and then copying it in. So we're gonna have a vector of ints like 0, 1, 2, 3, 4, whatever. And then let's put that in the map. So v1 equals, this is gonna be 1 because it's v1. And then we're gonna have map, and then let's make another vector in here just to test that that works. I know 0, 1, 2 or something, and that's vector 2. Then we have to check that it's hashed. So we're not gonna test this directly, because doing that's a bit of a pain when dealing with a struct, like with a hash struct, because we have to call the operator parens in it. So what we can actually check is that the inner map works, because if it works, then that means the test has to be passing. Like if another map works, then it means that the elements are hashed, otherwise it would be yelling. So let's just check the hash. Oh, sorry, it is hashed. Let's just check that it's actually hashed. So we should be able to retrieve the elements from the map. So let's do require, because we're gonna test that when you call get on the map with, let's say v1, you get a 1 back. And then require, then when you call map with 0, 1, 2, you get a 2 back. So now in theory, if I wrote everything correctly, which is this trash, this should pass. No, it didn't pass. Okay, why didn't it pass? Probably this is not how you do it, isn't it? Huh. Okay, let's make a temp vector. That just has 0, 1, 2 in it. And then let's pass it in here. I think this should work. This is not the hasher's fault, by the way. This is something to do with the map. Okay, there we go. Yep. So 2 assertions, which are these two, in 2 test cases. This is just another test case, so it doesn't really matter. I can comment it out. But yeah, so that's kind of how you write things in Catch. It's kind of a bit of a pain in the sense that you're actually forced to document your code, and that's always what takes the longest, you know? But also, you're forced to document your code, which means that if someone else were to look at it, you know, you would kind of understand what's going on here. Like, okay, I'm trying to test that this works, and I'm testing it that way because, yeah. So like I can add comments, and you should add comments to this. But if you don't, or if you forget, if you're lazy, or if you're tired, and you don't, then it's not the end of the world. Versus like here, where if you don't add comments, it's kind of you don't know what's happening, unless you actually like go deep into the code and check, okay, what is this supposed to do? What is this doing? Like, yeah. So that's kind of how you do it. And you don't necessarily have to do it, but it would be cool if when you were gonna write a test for empirical, you could like have a little scenario where you can test something with BDD instead of like the normal test case. And yeah, does anyone have any questions about this? No questions? Okay.
What I've got a question.
Yeah.
Does Catch have like how did you find out all these Catch features? Did you go read the
Good
Catch
question.
documentation, or was there like a blog post, or how did you start digging around?
I actually looked up, just Googled Catch 2 and then went to their GitHub, and then they have like a little on their GitHub at the bottom, they have some documentation that kind of tells you like, you can use BDD with Catch. And I didn't know what BDD was, so I had to do research into that. But then it seemed pretty neat. They also have a lot of documentation. Like I found out the require throws with from the documentation. Like they have a lot of things written that. Actually, I will link that. That's a good idea. I'll link you the documentation. Let me go find it. So here. Let me open the chat. Here is the section where they talk about test cases and sections. It's more in depth. It's very in depth, and they kind of show you how everything works. And they have these little examples that also show you in a very trivial way how you will use them. But yeah, you can go through their wiki, their GitHub wiki, and then just read everything. It's actually it's in depth and it's not that long, so it's kind of like a fun activity if you're into that.
Awesome. I'll be sure to post these links on the little web page for today's seminar too.
Yep. And yeah, I think if no one has any questions, I think Alex was going to talk kind of about BDD in JavaScript.
Sure. One other really cool thing about Catch is that, and you might have mentioned this at the beginning, it's it's a header only thing. So there's just a header you need to include, and that's it. And
Yep.
So it's like really low overhead to use for your personal projects.
And we were actually checking with Matthew earlier today how we're checking how long it takes to compile a file and why it takes that long. And Catch was actually they had little overhead when it comes to compiling. So that's actually really interesting. It's a tiny library and it does a lot. So you can just include it. I think it's a header only library. So you can just include a header and that's it. And yeah, you should use this in your projects if you can, or something like it.
Right.
Alex, did you want me to say a few words about Mocha and Karma overall first, or do you want to go first?
Yeah, but real quick, I want to just see in the audience who here is working with empirical web tools. I want actual little reaction emojis.
They might not all have access to reaction emojis.
Oh, okay. Well,
we're not giving access.
I see them.
Okay,
we can raise hand.
Okay, I see 3 reaction emojis, which is not true because I know some other people. Okay, there we go. 4 reaction emojis. All right, so for some of your projects, you are working with Empirical's web tools, which are these weird mashups of C++ and JavaScript. And so for all of the more traditional, so for the test that Santiago we're talking about, those were all written assuming native compiled C++. So the normal workflow where you have your C++ compiler, you compile it down to machine code for your local computer, you run the test, and you see if it all works. For the Enrichment web code, it's a little bit of a funkier workflow where you are writing some C++ code that has some JavaScript code, and you're going to compile into JavaScript, and so you sort of want to test it with a JavaScript testing framework. And so that's what Emily is going to talk about, give an overview of.
And Alex is also going to talk about more specifics of it and some really great improvements he just made to it. Right, so Catch is a great testing framework to use if you're writing pure C++. But if you're in this weird zone where you're writing C++ that writes JavaScript, you can't really use a C++ framework to do that. I mean, you sort of could. And when I was setting up the original web browser tests, I explored that possibility. Because, you know, with those unscripted macros, you can have returns. So theoretically, you could like have your JavaScript code return something and like try to test it that way. But ultimately, then you're like really fighting with Emscripten to get the information out of JavaScript that you need. And often like the things you want to check in JavaScript are like, you know, does this JavaScript object like have the right properties? And things like that are much more of a pain to pass out of JavaScript. There are tools, but it's easier to just deal with the things in JavaScript. And so that's why we settled on using a JavaScript testing framework. So basically when we're writing web tests, we are writing the majority of the code in JavaScript so that we can use the JavaScript testing framework. And JavaScript, being a more modern and popular language, has a variety of testing frameworks out there. All of them have various pros and cons. Some things that the empirical tests needed to be able to have are the ability to test code that has to run in a browser. So I don't know if any of you are familiar with Node, but Node is like a way that you can run JavaScript on the command line. And that's great. And we currently use that to test like JavaScript versions of some tools that don't require a browser. But some of our tools, like, you know, all of the stuff for making like web pages and all the D3 visualizations kind of do require a browser because you're manipulating the HTML DOM of the page. And so we needed something that would work in a browser. And we also wanted something that would like, you know, kind of like Santiago was just demonstrating with BDD and Catch, give us like useful framework for understanding what the tests are testing because they are unpleasant enough as it is. And so forcing there to be some self-documentation makes them at least somewhat interpretable. And also they're a lot more interpretable now that Alex has worked his magic. The original ones were pretty rough because in order to get stuff into JavaScript, you end up like kind of forcing a bunch of like C++ code to get compiled into JavaScript in specific ways that allow you to access it. To that end, we ended up settling on Mocha, which is a popular JavaScript testing framework that has a variety of different ways that you can kind of like structure your asserts. We're not using the most BDD-like one, but we're using a somewhat BDD-like one, where we have kind of like those like, well, you'll see them when Alex demonstrates them, but we have statements where we're describing a given object and asserting properties that it should have. And then kind of the other side of that is, so that's like the framework we use to write the tests. We also need a way to automatically run the tests that will deal with the fact that we're running them in a browser. And in particular, a challenge is that we're really hoping to be able to run them on Travis CI, which is a tool a few people have alluded to so far, which is basically, it's a continuous integration server. And the way it works is that every time we push code to GitHub, it automatically runs all the tests for us. And that's really great. So we want to be able to do that. It's command line though. So that makes testing browser stuff more challenging. Fortunately, it has this headless version of Firefox that it can just run. So as long as we have a framework that lets us use Firefox, everything kind of magically works, and that's great. And so the test runner that manages basically like looking through the Mocha files and like wrangling them into tests and giving us nice output about which test passed is called karma. And for those of you that read the optional blog post, there's much more rationale there about those choices. But that's the super high level view is, yeah, we're writing C++, we're converting into JavaScript, we are then writing pure JavaScript that tests it using the Mocha framework, and then we are running that using the Karma framework. Yeah. Is there anything else I should add, Alex, or do you want to go from here?
I think so. Obviously, you'll jump in as I say wrong things and supplement the inadequate things that I say.
We'll see. I mean, you're the expert on like the awesome new way of doing this.
I am, okay, so I will share my empirical, yeah, I think this will work. Okay. So I think what my plan was to show you guys kind of an old example of kind of using the Karma Mocha framework. So a while ago, Emily had written tests for the D3 wrapper using Mocha, and so that's in here. And then talk a little bit about this new tool that is currently in a pull request that should get merged into empirical pretty soon in the next day or so. That helps us write and manage Karma and Mocha, or Karma Mocha tests. And then we can live code a test for the element class, because there is no test for the element class currently, and the element class should be a pretty easy thing to test. Right. So let me see if I can scroll down to the actual JavaScript stuff. So, okay, so here, I'm inside the tests/web directory of empirical right now. And I'm in this visualizations.cc file. And so this contains the original tests for the D3 web visualization code. And you'll notice that it doesn't have all those fancy catch macros. Instead, it's got so this is some empirical web stuff. So it's got these structs, and then it's got, so some of you who are working with empirical web tools will recognize this code. So this is saying, here's a document, and here's another document class. And so it's got all these web components that are kind of floating around in the global namespace. It's got some functions that sort of organize the tests as best, like as encapsulated as is possible when you've got all this stuff floating around in the global namespace. And then, so there are more test functions. Okay, and here we get to where we actually drop into the Mocha testing frame code. So you'll notice we're inside the main function now. We JS wrap a bunch of those test functions. So we're saying, so if you're not familiar with the empirical web tools, this fancy cool function will take your C++ function, it'll wrap it up behind the scenes and give you a function that you can call from JavaScript, which is really handy. And so we're wrapping all those test functions, and then we drop into the Mocha tests. And so the way that the Mocha tests are laid out they are these kind of nested, basically you have your describe so everything inside the describe should describe how, in this case, the line graph works. And then inside, usually inside of describes, sometimes you have nested describes, but in this one, it's not nested. So we're describing a line graph. And I'm going to skip this before for a second. And we have a bunch of its. And sort of the nice, cool thing about Mocha is that like the code reads nice. I think it reads nicely. So we're describing a line graph. It should have data points for each piece of test data. And then here is some code that tests that. And then, it should also, they should be connected by a line. It should have an X and Y axis, etc. And so thing that you'll notice that is useful to notice, I guess I have to, okay. And so one of the other cool features of Mocha are it has these like before functions. So if you stick this before function inside of this describe, before each one of these its, this chunk of code will run. Or wait, no, that would be the before each. This is just before any of these its run. I think this just runs once.
Yeah, that's accurate.
Okay. I think there is also a before each that would run before each one of these. Right. And so a lot of these tests are basically, we are calling a function that was written in C++ and wrapped into JavaScript, and then testing aspects of it on the JavaScript side. Yeah, that's like an overview of how this works, and especially how kind of the workflow of how we used to write web tests. Are there any questions?
I have a question.
Yeah.
How do you run it, and what kind of stuff do you need to like do to install locally before you can start running this stuff on your own machine?
Good question. Okay, so before you start running the web test on your local machine, so in empirical, there's, I think in the root directory, if you do make install - dependencies, it will install the kind of prereqs, and I think under the hood, it needs Python, it needs pip, it needs the Python virtual environment thing.
I think the Python is actually for the other tests. No, I'm not sure.
Is it for the node tests?
Maybe, yeah, I feel like the web tests don't actually need Python.
Okay. Something needs Python, that is a dependency. Okay, so for this, you need basically Node and Karma.
You also need Mocha and Chai, which are both JavaScript libraries that like are very easily installed with Node.
Right. Yeah, I basically always just type make install test dependencies and it installs magic.
Are Karma and Chai and the other things that you can install with Node, those are in like the Node package manager file, so that should just all get
there's a
installed
package
automatically, I assume.
File,
yeah.
And everything in it gets installed.
Yeah.
Right. Okay. So those are dependencies. Running them. So in terms of, let's say I'm a user and I want to run just the web tests, you can go into tests/web, and there's a make file and there's a run test file. So if we pop open the run test file, this one is going to be different than the one that you probably have locally right now. Although this one will take the place of the old one in a day or so. It's basically a bash script, and the first thing that it does is it sources some Enrichment environment stuff. Then it calls make, so it runs this make default target. So this make file will take care of compiling all of the tests. And then it just loops over the tests, and for the Karma, this is the relevant code for the Karma stuff. It just calls Karma start with the configuration file that's inside of this directory, and then the file name that it's testing. And so Karma, instead of the test being like, right, so Karma basically runs our test for us. And that's very relevant to keep in mind while you're writing your web tests if you're using the Karma Mocha framework, in that Karma is going to make the HTML file for you. You are not making an HTML file. So like I know whenever I'm writing web code, I often want to test it by building a little HTML file and seeing if my web code interacts with the HTML file visually. That's not how this works, which can be annoying while you're writing the test, and also means that you have to do a little bit of extra work when you're setting your tests up.
You can always write an HTML file to help you write your tests, though. Like,
Yes.
that's 100% legit and usually a good idea.
Yes, true. But when the test gets run on Travis, it's not going to pay attention to your HTML file. That turns out to not be a huge deal for reasons that we'll get into when we live code. Okay, so that's running the test, which again we'll do when we live code. I want to real quick jump over and give an overview. Actually, no, I'm not going to give an overview. I'm going to skip it. Let's just start live coding a test. So I am right now inside of test/web. I'm going to make an element file. So we are going to test the element class in the empirical web stuff. And so if we go look at the element class, it is 42 lines of code, and most of those lines are boilerplate. The actual class is, how many lines is that? Is that 9 lines? Because all it does is it inherits from div and tells div, hey, I'm going to have this tag and I'm going to have this name. And that's it. So in theory, we should be able to live code this out right here. Oops, don't look at that. Yeah. Okay. Yeah. So for these web tests, we are going to have a main, and actually, I'm just going to copy over some boilerplate from widget. So I'm just going to copy over some includes and this top bit. We are going to use a fancy new feat tool that we wrote in the D3 wrapper group that will manage our test for us. And what we need to do to write a test is to struct test, and we're testing an element, so I'll call it this. We're going to inherit from base test. Okay, so it turns out that Enrichment compiled code and Mocha describe clauses do not play well together out of the box. Like, so this test manager class kind of smooths out the hinges between Mocha and Enrichment. And I don't need to get into the details as to why they don't play well together without some tricky glue, but they don't. And so the way that this manager works is it will run tests for you that are derived from this EMP web base test class. And I can pop over and show you what the base test class looks like. It's really simple. It has, the important things are, it has a setup function and a describe function. And these are the things that you are going to override in your test. And all that you need to know is that setup gets run before, well, setup gets run first and will set up your test, and describe gets run after setup and should have inside of it your Mocha describe clause. Okay, so with that, we know that we need to do a void setup override function, and we need a void describe override. And then what we can do now that that exists, the way that we tell this test manager about that object or that test that we want it to run is we say add test, and then we tell it the type, and we give it a name, test element. And so, right, so you'll notice that we never actually construct this test struct. We leave that to this test manager. So then we can also do, and when we want to eventually, after we've added all the tests that we want to add, we can do manager.run, and that will run all the tests. I could compile this right now, and it actually, I don't even think it would, it might work. There are a few more little things that we need to do. Right, okay, so our test element class is going to want to interact with the HTML document because at the end of the day, we want to test whether or not that element gets created. So I guess a little background on the test element, on the element class, if you're not familiar with it, is it basically manages an HTML component. So like you can have like a paragraph, like you might have a paragraph tag or a whatever, all the other a div tag or header tag, h2 tag, et cetera, et cetera. All of those are HTML elements. And so you can use the element in scripting class or element empirical class to make one of those things and shove it inside of an empirical document. So we need to tell the, so we need to do a couple of like little setup things. The first thing we need to do in any of these tests that use empirical is actually tell Enrichment that, hey, empirical exists, I promise I'm gonna use it, which is what this EMP initialize does. And then because we're gonna be manipulating, or we wanna test things that are on the HTML document, we need to give ourselves sort of a place to attach HTML to. Because remember, Karma is creating our HTML document. So we have to use JavaScript inside of our test to attach any HTML that we want to be inside of that document. And so here, just whenever this code starts, we want to just immediately say, okay, I'm going to attach this div that's called, that has the ID EMP test container. It doesn't matter what the ID is, to the body of the HTML document. And so this is just going to shove this at the end of the body, which is fine for us. The other thing that's useful is that the manager class will do for us is it has this nifty on before each test function. So we can tell it to do things before each test gets run. And it doesn't super matter for this test file because we're only going to write one test, and that's this test element thing. But if you were to break this up into multiple test structs, so maybe like you didn't want to test element with just one struct, you wanted to test a whole bunch of different components of element, each with their own little encapsulated space, this is more useful. But we sort of want to reset the context of the HTML document between each test so that things left behind in our first test don't gunk up the document for our subsequent tests. So that's where this comes in. So the manager is just anything that you tell it to run before each test, it's going to just call this little lambda before each test gets run. So what we want to do is we want to use jQuery to select this and call empty on it. And I think all this is going to do, the thing that I need to do is be inside of, this is JavaScript code. Okay. I think I wrote all the things here correctly, but I'm not sure. All this is going to do is grab this, select this div, and then clear it out.
Are you passing that EM ASM macro into the argument part of the
Oh, good. Yeah, okay. Yeah, this is why live coding is not. Live coding's great. Oh, God, what did I do? I should just do what Matthew does. Okay, so on before each test, we're passing a lambda. The body of that lambda has this. Okay, that should work, I think, except that I didn't close this. Now that should work. Probably.
Also, your test manager is currently called Manger.
It is indeed. All right. Okay, so we have this. This is sort of like we've written all the boilerplate, and I'm hoping in 9 minutes that we can actually flesh out this test. The other thing that we should do real fast is set up the empirical, like tell the make file and the run test file that this test exists now, now that it's in sort of a minimally compiling form. So that's pretty easy. I'm just going to use widget as my template. So I'm going to copy and paste the widget target and call this elements, and this elements, element. And then if I want to be a good person, I do element.js here. And then, okay, so that takes care of the make file. So now if I do make element.js, it should try to compile our element test. And the other thing we need to do is hop into this run test function or script and tell it about element, which is easy. So thing that you'll notice here, okay, this didn't compile, that's cool. There are 3 categories of tests that we expect to exist inside of the web testing framework for empirical. There are these catch tests. And so these are things that for whatever reason, you don't actually want to compile to JavaScript, you just want to run it as a catch test, so you just want to compile it to native C++. And these are tools like the color map that are basically a bunch of C++ functions that build strings for you that you can then give to JavaScript, and JavaScript knows what to do with. Then there are node tests. So these are tests that just you want to run with Node, and they don't need a browser or anything. So get URL params is an example of that. And then there's these Karma web tests. So these are the ones that are the Karma Mocha things. So we want to add ours here. Okay, and so now that's all the setup. So this did not work for whatever reason. Why did it not work? Oh, because this is EMP web.
In the make file, is there like a list of targets at the top that you also need to add it to?
Oh, probably, yeah. Yes, definitely. I think we could automate this a little bit more.
Yeah, there's some make file magic that would do it.
But for now, that's fine. Okay, so our little minimal test passed. And actually, instead of running all the tests, I'm going to just copy this command to run just this test. So if I say element here, you'll see all this nonsense. So this is basically a Karma configuring itself, building an HTML file, firing up a web server, running a headless Firefox, and oh look, our test ran, and everything passed. Great. Okay, we have 6 minutes, so instead of actually real live coding, I'm just going to copy over stuff that I wrote earlier, and I'll talk about it as I do that. Okay, so in this test element, we are going to want our tried and true document object. So for those of you who've used empirical web components, you'll be very familiar with the document object. The way that it works is when we construct it, we pass the ID to a div, ideally, but HTML element that is in our document, that then, our HTML document, that this object will then sort of take control of and manage, which is useful because we can shove stuff into it. Other thing to note when you're writing web tests that's a little annoying is that the empirical web tools were not built under the assumption that they would be run in this weird Karma headless browser thing. So it turns out that when you construct this doc, or this document, it sort of assumes that you're going to construct it before the HTML file, like the ready trigger, or the ready signal is triggered. And so what this is doing is it attaches its sort of activation, or like a lot of its initialization stuff, to the ready signal. And unfortunately for us, because we're doing this weird, bizarre web testing stuff where this object isn't going to get created until way after the HTML document trigger or signals that it's ready, we have to manually tell it to do its little activation magic. So basically we just say, hey, document, be ready to activate, and then use jQuery to trigger the browser's ready signal, which will then tell this to actually construct itself. Right, okay. And then let's just, so we're actually testing the element class. So the way that you make an element is, let's see here, we have an element called header. It's going to be an h1 element, and its ID is going to be element h1. We're going to use the stream operator to shove the header, our header element, into the doc. So we would expect that there'll be a div with the ID EMP test container, and inside that div will be this h1. And inside that h1 is going to be the string header exclamation mark. Okay, and one more thing that we want to do just to make sure that the document actually updates is we're just going to tell the document to redraw itself. So these two bits of like boilerplate, if you've used empirical stuff before, you probably haven't had to mess with these two things. The only reason we're messing with them here is because, again, we're using this like bizarre, we're breaking a bunch of assumptions that empirical's web tools have about when they will be created and used. So when you're writing your own web test, if you're working with web stuff this summer, feel free to jump over to like widget.cc, or I'll upload this and just copy and paste these sort of things into your test. Okay, 2 minutes. Let's see if we can write an actual describe. And by write, I mean, oh no, we can write it. We'll write it. It's easy. Okay, so in this describe, so in our setup, all we're doing is we're creating this element and we're shoving it into the document. So in our describe, we want to drop into JavaScript and make a describe, and we're going to describe an element, and we're going to do that. So I'm also going to do this. We're also going to just do, so for lack of time and creativity, I'm just going to say we're describing element. We're going to describe this element h1 thing that we made. This is bad practice according to the talks we just listened to, but it's okay. Okay, so element h1 should exist. I think that's all we're going to have time to test. Function. Okay, so to test that it exists, I think we can do select it element h1. Is it just blank? I'm cheating. Yeah. Okay. So I'm just going to copy this in. Okay. So what this line of code is saying is we're using the chai library. We're asserting that whenever we use jQuery to search for EMP test container, and it returns like a list of junk that it found, the length of that junk should be 1, because there should only be one. There should be one thing called element H1. Okay, and I'm going to just compile it.
Oh, I think you need to change the anymore element.
Oh, yes, this should be. It should still pass because there should only be one of those, but you're right. Okay. I hope this passes. Are there any questions? Because we're basically at time. Hey, it passed. Element H1 should exist, and it does. Well, okay, I think it was actually testing EMP test container, but hopefully this would exist. Right. So that's how you write an empirical web test at the moment.
So what's the timeline in terms of students who, or participants who are currently working on web projects being able to have the tools in main so they can port it over to their branches and start writing tests like this?
Hopefully later today. I mean, I just need, the pull request is basically good to go. I'll push this element.cc up because why not? But it just needs 1 or 2 people to review it. And there are like 1 or 2 discussion points, but I think it's good. It's good to get merged in.
Cool.
So I'm hoping by the time you go to write tests and for whoever's working on empirical web tools, you can use this test manager to run your tests. And I'm also happy to like field questions about how to use it on the Waves Slack.
My other really quick question is, does this feed into coverage statistics at all?
Fortunately, no.
Not at all.
Because, Emily, do you want to?
Sure, yeah. So that's a challenging thing to achieve because we need a way to keep track of the lines of JavaScript that get run and then cross-reference those with the lines of C++ or like whatever, code was in this original .cc file that generated those lines of JavaScript within Emscripten. And then we need to like do the stuff to be like, oh, did they get run under the tests?
Oh, wow.
Yeah, I've like thought about it a lot. I think I know how you would go about writing it. If anyone like ever wants to take a stab at it, like please do. I'm happy to give you my thoughts. But yeah, unfortunately there aren't any tools that exist for that currently because this is a weird thing that we're doing. So yeah, currently no coverage for web tests.
When I Googled around a couple days ago, there were like maybe 1 or 2 blog posts that like had proof of concept, like really simple proofs of concept, but nothing that was like we could just bring into this project and use. Like they had just written the code that could do the back, basically the cross-referencing.
Yeah.
Yeah,
I have some
good tools for that.
I have some more questions about that, but I can ask another time.
Sure. I mean, or if no one else has questions and like people who are interested want to stay on the line and talk about that, we could also do that.
Yeah. Okay. All right. Well, then I guess we'll end the official session, but anybody else who wants to hang out and talk about, do some more questions or whatever is more than welcome to continue hanging out. So my question is, could we get, so test coverage ideally will tell you what actually runs, but could we do like bad test coverage where it just tells you what even gets compiled for a test?
Oh, kind of like force cover does.
Yeah.
That might be easier.
Yeah. Because
yeah, I mean,
then
actually,
that
we could do
would,
something pretty similar to what force cover does.
yeah.
That'd be a start.
Right, and then we would have the all important Travis or CodeCov yelling at you for merging in something without writing any tests at all.
Yeah, that would be good. I mean, I worry about it, and then it might give us a false sense of security because,
Right.
like, of all things in empirical, the web tests are the ones where it's most true that just because it compiles doesn't mean it works. Because, like, you know, the JavaScript could do anything. It could be like completely not like legit JavaScript.
Right.
But yes, I think that is worth considering. Although also, like, I don't know, if we're gonna go so far as to write that, I almost feel like, I mean, no, like getting actual like code coverage for what runs like would be a step farther, but like,
Yeah.
What is your idea for that? Or your thoughts?
okay, so I mean, what you need to do is, the technical term is instrumenting the code, where you add basically like additional machinery that like keeps a counter of every line, and like the number of times it's been run. It's like there's a map, and it's like, okay, line 1, I'm incrementing your counter for times run because I just ran you. And LLVM has equipment for doing that, and Emscripten is built on LLVM. So I haven't confirmed that Emscripten will play nicely with the LLVM instrumentation, but I think it does. And one of those blog posts, because I also Googled this recently, Alex, like I think one of them implied that it does, right? Was that your interpretation too?
I think so, because it seemed like they had just sort of used LLVM.
Right, yeah.
And wrote kind of like glue code to put it all together.
Yeah. So like I think you could do that. And I think Emscripten does like know which line of source file each line of JavaScript came from. So like I feel like the ingredients are there. It's just probably really badly documented. So the actual process of like putting the ingredients together in a way we can use is probably going to be time consuming and unpleasant.
Yeah.
Yeah.
But yeah, conceptually, I think it's actually not that hard. But I mean, conceptually, force cover shouldn't have been that hard to write, and it like definitely was. For those of you who aren't familiar with force cover, it's like a little utility I wrote that basically catches code that. So when you have templated code in C++, if you never instantiate the template, like it never gets compiled, and so code coverage utilities won't even notice that it's like something that could be run and isn't being run. And so force cover is a thing that like modifies the coverage report to like say, no, really, this code should have been run. Yeah, I mean, it would be so nice to have it working. I totally agree.
Yeah, I guess the question is like, where do we, like, this seems like it would be something of the difficulty level where I don't think it would be fair or beneficial. I'm not choosing quite the right words that I mean there, but like for a graduate student to do it, if that's not their research area.
Right.
Right, exactly. Like, I don't know who could do it.
An
Because, like,
enterprising undergraduate who is very familiar with system, like low-level.
Yeah, like if Cindy were still here, I might be like, okay, yes, you could do this.
Yeah.
Yeah.
I wonder if we know Cindy has a job and Robin has a job.
Or Jake. I
That
guess
could be fixed. That could all be changed, you know.
Yeah.
I could see Jake enjoying doing this too.
Yeah, definitely.
But they all have jobs, and
They do. It's so unfortunate.
I wonder.
You people always thinking in the short term, always thinking in, you know, what exists now. Possibilities, people, possibilities.
I wonder if this would be something where like we would need to find like a chunk of change and like hire somebody to actually do this.
Oh, that would be really expensive, I bet. Like to find somebody that has like the skills and is like also a professional software developer.
Yeah.
Like those people could earn a lot of money.
Yeah.
And here we have the problem with academic code.
Yep.
and this library is like, in terms of academic code goes, is like way more well tested than, you know, most academic code.
Oh yeah.
So Enrichment has a flag that's like G4 that makes a map between the C++ code and the browser's debugger. Could that be used?
Yeah, I think that would be part of it. Like we would turn on that, we would turn on the LLVM instrumentation. And like it feels like if we turned on all of that, we'd be most of the way there. I just
Right.
like feel from experience like we wouldn't actually be.
Yeah. How did that blog post that you and Alex read, did this person talk about it like it was a nightmare, or did they talk about it like, oh, this was a thing that I did and that just happened?
I mean, they seemed like they thought it worked surprisingly smoothly out of the box. Was that your interpretation, Alex, too?
I think so. So is this the Motley Coder?
I think so.
Because it's like one of the only hits.
Yeah.
Yeah, I think that like they had an idea that they didn't think would work, and then it worked.
So, I mean, that's encouraging. I mean, it is possible that like literally like we could just like do what they did and it would work. And we need to do like a little translation maybe to like make it be a format that CodeCo would be okay with.
Right.
It's possible that it could just work perfectly the first time, completely smoothly, absolutely no.
There's a non-zero possibility.
I mean, it might.
Has that ever happened?
It might actually output like, so does like the LLVM cov thing output stuff in a format that CodeCov is happy with?
You have to do a few things to it, but yeah, I mean that's like actually how we do most of our CodeCov stuff.
Because it just like, that's what the blog post is, like the final part is running that tool and
Okay, maybe we should try just doing what the blog post did.
Well, doesn't like G4 output a map or something? I don't know. Like, who knows what that file actually is? You know? Like it's
I think it's like literally like
just a
mapping between lines in C++ and lines in JavaScript.
So I was just reading the last couple of steps that this person took. They compile with the, let's see, F profile instruction generate flag, the F coverage mapping, and then they output it to a .bc. Let's see, output an LLVM bitcode file, which is apparently useful. And then they use Clang to load the bitcode file and turn it into a native static library.
Oh, right. That was the part where it lost me. Because, like, is it clear to you from that how you run the JavaScript version and then
Oh.
Could you link the post on like the empirical or?
Oh, yeah.
What? So it's.
There's a channel called Empirical, and it is right here.
Oh, did you get the Empasser to work? Like to fail when it should fail?
The Okay, I also posted here. Okay, sorry. What was that?
Did you get the Empasser to like fail when it should fail?
Oh, no. So where we are there is everything else will basically work at this point except for Empasser.
Oh.
Okay, so just don't use Epicert in a file that you're supposed to test with Mocha.
Right, and I think that I don't really feel, at the moment, I don't feel like I want to commit the bandwidth to making Empasert do the right thing, but
Yeah, I don't think that's necessary.
all we would have to do is either make a new Empasert macro or have some compiler flag that we could turn on that would just cause it to abort when it's compiled with that flag, instead of doing what it does now, which is just print the stack trace to the console and send a browser alert. So it actually would not be hard at all. I think it would just be copy and pasting some code and deciding what that browser flag is. I am going to not do that because I already spent too much time on software development stuff for the week. So.
Good choice.
We should at least open an issue and paste all the stuff in there.
Yeah.
That's a good idea. Yeah, like here's the starter kit for if you want to tackle this.
Yep. And the other thing I was going to encourage, especially Alex and Santiago, if you could paste like some representative like code snippet or whatever that you used or had prepared for the thing into that little chat, and then I'm just going to go through that chat and like put all that stuff on the site. And if Alex, if you can save the recording at the
I'll go ahead and stop the recording now.